video demonstrating the suspension capabilities of the robot. As you can see, it's quite bouncy, quite durable. Constructed out of a what's left of a table. As you can see, there we go. Made up of a square, 30 centimeters by 30 centimeters, with bottom bar. See the spring system. These springs are really very durable, as I have just demonstrated. These all provide off-road movement. This is one of the other bars. This will sit like that. Of course, this robot is upside down at the moment, but the final version will look a little something like this. This is the track I got. You can see extremely tough rubber, very strong plastic. Yeah, it's very tough. This is brilliant for off-road, so fit that in there, fit that like that. As you can see, the track will sit there, and then curl around. The wheels will then go side. Well, actually, the track will be about this sort of height. The wheels will then sit in there. Suspension springs give suspension, so the track itself will come up to about that sort of height. So the robot will be about, its drive system will be that high, and you can see it has massive clearance. I mean, turn it upside down, it's going to have that much clearance with about this much extra. So it's going to have about that much clearance, and as you can see, it's really lightweight. You know, it weighs almost nothing. I mean, I can hold that just like that. It weighs absolutely naffle, so it's very lightweight, very strong. I just demonstrated it can hold my weight. I'm not a light person, I'm quite a heavy person, about 100 something kilos. So it will support the weight of the robot very easily. Over here, we have the propulsion system, the motors. As you can see, got 1 motor, 2 motor, 3 motor, 4 motor, all will be controlled by the Sabertooth, which is this funky little thing here with heat sinks around it. This is the brain of it. Arduino Mega. Very nice little bit of freeware stuff. This will 52 pins. That will control the robot, tell it what to do. Drive sprockets. These will attach onto the end of the motors, like so. These will rotate. The motors will sit. Sorry for all the walking around. Motors will sit, putting the robot back just all the right way. The motors will sit, if I lay the track out, motors will sit here and here, inside of course, so the motor will be here and up here, so you have rear wheel drive and front wheel drive, which will give it additional push, because it'll be pushing and pulling at the same time, instead of traditional tanks which have rear wheel drive, which gives a lot of push, but it doesn't necessarily allow for a lot of speed. This will also double the amount of torque it has and double the maximum speed it can go, so it should hopefully move at a fairly swift speed. I'm expecting about walking speed, nothing too drastic, but of course we'll see when I get it all wired up tonight. I've got a mess on my thumb. This will be powered by 2 motorcycle batteries, 7,000 milliamp hours each, which will give it 1,400 in total, which means it can last for a good few hours before running out of charge. And these are really cheap. I got them off a scrapyard, so I'll probably pay another visit at some point to get 2 more, because I'll design the batteries so they sit in the robot. You can just disconnect them when they're dry, plug in new ones, connect it all up, and they'll run. So you can have 2 charging while the other 2 are running, which will give it a very nice lifespan, especially if you're using it for airsofting, as you don't want to be changing batteries constantly. So big batteries are the best thing. They're like a £5 each off the scrapyard. It just takes a bit of time to get them all fully charged again, because once they're fully drained, it's a bit of a bitch to get them trained up, but you can get special equipment to do that. So yeah, this is the framework of it. The weapon system has not yet arrived. I was hoping it had arrived today because I could demonstrate that by fitting an FNP90 to it. For those of you who don't know, it is, again, for airsofting. The FNP90 is kind of a standard SMG submachine gun, for those who don't know the lingo. which is a very reliable short-range weapon. That'll sit on the top on a rotating turret, so it'll be fully remote controllable, video camera, so you can see through its eyes, controlling through either radio or most likely through XB, which is unique to the Arduino, which will allow me up to a mile communication range. Weapon system will be on an independent circuit, so that should I need to cut power to it, I can just flip a kill switch and kill all power to the weapons, make it safe. LEDs will come on signifying the weapons are armed and ready, so anyone who walks past it knows it's dangerous. Height of the robot will probably come up to about here, I reckon. So, if I get the ruler out, it's already at about 20 centimetres. Add the wheels onto it, it'll probably be about 30 centimetres. So, top height of the robot will probably be about half a metre, so probably be about that high. Adding the weapon and stuff, which is quite nice for a robot. All in all, weight-wise, I have no idea what it's going to weigh at the final stage, but hopefully it shouldn't weigh too much. Right, and that's the end of the demonstration. Hope you enjoyed it.